Good day, everyone. In this video, we are going to take a look at the applications of differential calculus to rectilinear motion. As we all know that rectilinear motion is the motion of a particle along a straight line. It is usually specified as S is a function of time, where S is the distance moved by the particle by the body, and time t. Now what happens here is, if you differentiate this distance function as a function of time, we are going to get velocity. That is, when you differentiate this distance with respect to time, we are going to get the velocity of the body. And if you further differentiate this distance function, that is its second derivative, which is the square s, the t square, which is seen as you are differentiating velocity function, the v, with respect to time, it will give you the acceleration of the system. Now let us apply this to solve some problem. The first question here says that the motion of a particle along a straight line is specified by the equation 4t raised to power 4 minus 3t raised to power 3. We have to find the velocity and acceleration of this particle after 3 seconds. Now, if we say let S be equal to 4t raised to power 3 minus 3t raised to power 3. Now, to get the velocity function here, we have to differentiate this distance with respect to time, as I've said earlier. Then we have velocity, which is equal to the s dt. When you differentiate this, you move this one here to multiply this. This will give us 12. Then t, then remove 1 from the power to be t squared. Minus, you move this one to multiply this to give us 9. You subtract 1 from the power, it will be, sorry, this one is t raised to power, okay, from the question is t raised to power 4. So when you move it here to multiply this, it will give us t raised to power, it will give us 16 t raised to power 3. Then this one will give us 9 t raised to power 2. Now this is the velocity function. So we are asked to calculate its velocity when the time is 3 seconds. Then we find the velocity when the time is 3 seconds as 16 into, we substitute 3 for the time, which is 3 raised to power q, minus 9 into t raised to power 2. This will be equal to 16 multiply 27 minus 9 multiply 9. When we evaluate this one further, we have this one is 1627 minus 81, and this will give 351 meter per second. Then to get the acceleration of this one, what we have to do here is we further differentiate this velocity function. Velocity function v, which is equal to ds dt, is equal to 16 t raised to power 3 minus 9 t raised to power 2. When we further differentiate it, it will give us acceleration. That is the v dt, which is equal to the square s dt square. When we differentiate this 3 will come and multiply this 16. This will give us 48. Then we subtract 1 from the power. This will be t squared minus these 2 will multiply this to give us 18. We subtract 1 from the power, we have t. Then acceleration when the time is equal to 3 seconds is going to be equal to 48 into 3 squared minus 18 into 3. Then this will be 48 multiply 2 squared is 9 minus 18 times 3. Then we'll have, when you multiply this together, this will give us 432 minus 18 times 3 is 54, and this will give us 378 meter per second square. Let us take a look at question 2. This question says that the motion of a particle starting from O is described by the equation x is equal to 2 over 3 t cubed minus 17 over 2 t squared plus 21 t, where x is the distance in meter and t is the time in seconds. We have to find the acceleration of the particle when it is momentarily at rest. Now, what we need to do here is the distance as a function of time is given as x, which is equal to 2 over 3 t cubed minus 17 over 2 t squared plus 21 t. And we know before that, if we differentiate distance as a function of time with respect to time, we are going to get the velocity. And if we further differentiate it the second term, we are going to get the acceleration. That is exactly what we are going to do here. Now, when we differentiate this distance function with respect to time, we have the x, the t. When we differentiate this 3 will come here. This will be 3 multiplied 2 over 3. Then we subtract 1 from the power, it will be power 2 minus this 2 will come down, 2 multiply 17 over 2. Then we subtract 1 from the power, it will be power 1 plus, when you differentiate 21t, it will give us 21. These 3 will cancel this 3 and these 2 will cancel this 2. We have the x, the t is equal to 2t squared minus 17t plus 21. This is the velocity function. Now, when the particle is momentarily at rest, the velocity is 0. So when the motion is momentarily at rest, then v, which is equal to the s, the t, is equal to 0. For that, we equate this to be 0. This implies that 2t squared minus 17t plus 21 is equal to 0. This is quadratic equation. When we factorize this, we are going to have 2t minus 3 into t minus 7. Then we equate it to 0. Then here we are going to have our t to be equal to 3 over 2 or 7. Now let's keep this and differentiate this velocity function with respect to time to get our acceleration function. That is, if we differentiate this one the second time, we have the square x, the t square, which is equal to dv dt, which gives acceleration, is equal to, when we differentiate 2t squared, it will give us 4t, minus, when we differentiate 17t, it will give us 17. If you differentiate 21, it's a constant, it will be equal to 0. Now from here, we want to find the acceleration when the particle is momentarily at rest. The particle is momentarily at rest at 2 different times. That is, when the time is 3 over 2 and when the time is 7. So we are going to find the acceleration at these 2 different times. That is, we find the acceleration when the time is equal to 3 over 2. Then we substitute t to be 3 over 2 into this acceleration function. This will be equal to 4 into 3 over 2 minus 17. And then from here, we have 2 here, 1, 2 here, 2. 2 times 3 to give us 6. 6 minus 17. This gives minus 11 meter per second. I believe you know what minus there means. It means it decelerates. Then let us look at what happened when the time is 7 seconds. So the acceleration when the time is 7 seconds is going to be equal to 4 into 7 minus 17. Here, 4 times 7, that is 28. 28 minus 17, this gives 11 meter per second square. Now, what it means here is at the time 3 over 2, it decelerates at the rate of 11 meter per second square. At the time 7 seconds, it accelerates at 11 meter per second square. Now, let us take a look at question 3. The question says that a body is projected vertically upward and the height h in meter reached after a time t in second is given by h is equal to 190 minus 4.9 t square. Then we are to find the time taken to reach the greatest height and the greatest height reached. This is an application of differential calculus. Now let us look at the solution to this. We are given the height as a function of time as 196 t minus 4.9 t squared. Now, when we differentiate this height with respect to time, we have the h dt. When we differentiate 196t, it will give us 196 minus, when we differentiate 4.9 t squared, this square we multiply 4.9 and this will give us 9.8. We subtract 1 from the power, it will be t raised to power 1. Then we know that when the body reaches the greatest height, the velocity is 0 because this is the velocity function. So at maximum height, we know that the velocity, which is equal to the h, the t, is equal to 0. Therefore, we equate this function to be 0. This implies that 196 minus 9.8t is equal to 0. This implies that 196 is equal to 9.8t. T will be equal to 196 divides 9.8. And when you do this, this will give us 20 seconds. And then after this, we have gotten the time taken to reach the maximum or the greatest height. That is the first part of the question. Then the second part, we are to find the greatest height reached. Now, since we have gotten the time it takes to reach the maximum height, then we go to the height function, which is h is equal to 196t minus 4.9 t squared. Then h will be equal to 196. Our time here is 20 minus 4.9, 20 squared. Then from here, 196 multiplied 20, it will give us 3920 minus 20 square multiplied 4.9 will give us 1960. When we evaluate this, it will give us 1960 meter. Thank you very much.